What the prototype stage is, it's an early sample created to test the concept or process that you plan on building. So in the first three stages, you talk about the empathize stage, the define stage, and then the ideate stage. So the empathize stage basically is getting to know the end user of your mobile application, of whatever you're planning on building, the problem you're trying to solve, who it affects, who the problem affects. That's the empathize stage. Then for the define stage, you basically are defining the problem. So once you've empathized with the user, you now identify the problem and then you define it. Once you've identified and defined the problem, then you can begin to think about the problem. That takes you into the ideation stage. So once you've ideated, basically get the ideas that would work to solve the problem you've defined in the defined stage. Then you can start to build. Now the building is where we are at now. That is the prototype stage, basically. All right. So, uh, so basically, the prototype stage is the early sample created to test the concept or process that you have developed. All right. So, head into it. Why is the prototype stage necessary? So, the prototype stage is necessary because many designers make prototypes to test their designs before investing in the final product. Because of this, creating prototypes is really the step between the formalization and evaluating of ideas. So basically, what I've been saying, basically, this is like basically what I was saying in better grammar, basically. All right. So when designers want to determine and understand exactly how users will interact with the product, the most obvious method is to test how the user interacts with the user interacts with the solution you've built to solve that problem. Now, if you do not build something that they can test, how do they test to see whether the solution solves the problem? That is where the prototype stage comes in. So the prototype stage is basically providing something that the users can test to see whether it solves their problem. Right. So now we understand what the prototype stage is basically and why it is necessary, because it provides an avenue to test. Right. So now we can move on. So before we continue, let's look at this quote by Tim Brown. He was CEO of IDEO. So he says, prototypes, they slow us down to speed us up. By taking the time to prototype our ideas, we avoid costly mistakes such as becoming too complex too early and sticking with a weak idea for too long. Can someone ex- um, can someone tell me what they think this statement means? I'll read it again. They slow us down to speed us up. By taking the time to prototype our ideas, we avoid costly mistakes such as becoming too complex too early and sticking with a weak idea for too long. Can one person unmute yourself and then try to explain what you think this statement means? Hello, guys. Hello. Mm-hmm. Okay. All right. Sure thing. Can another person try, please? Uh, all right. Yeah. Actually, good. Yeah. That's actually a very good insight. All right. So let me explain what I think this statement means. So this statement says they slow us down to speed us up. So under normal circumstances, before this whole design craze started, when somebody wanted to build something, the person just started building it, and so they didn't think about design previously, right? So now that design has come into it, and then the design process might take maybe 1 week, it might take 3 months, it might take a year. Now, that 1 year or 3 months in the past would have been used to actually start building the particular thing they wanted to build, right? But now that time is being used to actually do design, right? So that is, they slow us down, right? But the speed us up bit is that where the speed us but up bit comes in is, now it has slowed you down, but because you spend so much time to actually look at how the problem is and then how you solve it, it skyrockets you, it prevents you from making mistakes, it gives you the opportunity to make the test. And so in the beginning it slowed you down by taking up time to actually do the design, but it speeds you up because the time you would have used to start development and then make mistakes, you've spent that time doing the design. That's figuring out the problem and then identifying the user points and everything. So that is the first part. By taking the time to prototype our ideas, we avoid costly mistakes. So by taking the time, so in the period in which you took your time to actually do design and then you prototype, you do your testing, you realize that you've identified errors that could have happened when you if you didn't do the design and then just jump into development. Because you've done the prototype and then you've tested the prototype, you haven't invested so much money into building the actual product, which would be expensive to do. That's creating costly mistakes, such as becoming costly mistakes. So now one of the now the costly mistake comes with two things. It says, such as becoming too complex too early. Right? So now you are solving a problem, and then because you haven't prototyped, you realize that you are solving the problem, and then there's so much that you are adding to the thing you're trying to solve. There's so much you're adding to it that it becomes so gigantic, and then it becomes impossible to solve. So it becomes becoming too complex too early. Right. So one thing about design is there's something they call MVP, where minimal viable products, and then you build iteratively and then increase. So because you don't become too complex, must be done, right? And pilots had to go through rigorous training to actually fly the planes. So around World War II, when there was so much war and then people were dying, they needed more people to fly planes. And so they started thinking, how about we build a plane in such a way that it's easy for the pilots to actually use it? So that means basically cutting the training time into half or something. I'm not sure of the statistics, but it reduced the basically the number of hours pilots needed to learn how to fly planes. So the way it works in the question you are asking is, if you do not test the solution you are building, yes, you build a product, right? But would the product serve its purpose? Would it meet the end user's needs? If you do not test, how do you know? How are you certain it might work? There's no doubt on that it might work, but how certain are you that it might work? Are you willing to risk it, right? So that is where prototype comes in. You need to test to make sure that what you are building is actually solving the problem it solves, because there are solutions to problems that do not work. If we can agree that there are solutions to problems that do not work, then we can understand that if you do not test your solution before you actually develop, we spend so much money to actually develop it. So storyboarding, so for each scene, they will draw the characters and then put them in positions just to create a visual representation of what is going on. This is used a lot in like the animation scene, where basically just to capture how the story would unfold. So it's like a visual representation of how things would unfold, but it's all done most likely on paper, or like if you have a digital pen at home, and if you have a Wacom tablet or something, then you can do it digitally on a computer. But it's a visual representation of something. It's in no way or form what the final thing might look like. Then sketching, again, sketching is just like storyboarding, but with sketching basically like, you know what a sketch is? It's like a fast what's the word? Like a fast way of putting down your whatever is in your head, like basically visually. And then there's this other thing called card sorting. So card sorting is a way of, when I think of card sorting, one of the situations in which card sorting is used is when it comes to information architecture. So card sorting helps us understand the way people think so that we can arrange content in the way that makes sense to them. So like if if I'm arranging like if I'm arranging stuff like say content on a screen, and then I want to see messages I've sent, messages I've received, messages I've saved, messages that I spam, you know that it makes sense to categorize them into one group called messages. So basically, card sorting is we scatter all the information on the table and then we ask people to arrange them in the way that makes sense to them. So based on how they arrange them, then you can see the pattern and then know that, okay, people associate this to this and they associate that to that. So like basically it helps you create information architecture where you know how people are. So once they do that, then you know that if somebody's looking for sent messages, they know intuitively that in their head, they know intuitively to go to messages to find card messages. Does that make sense, please? Hello, guys. Hello. All right, fantastic. All right. So these are like 3 of the most popular low fidelity methods. We'll head into, so look at some of the pros of low fidelity prototypes. So first of all, they are quick and inexpensive, and so like, of course, obviously, when you're doing something fast, when you're pouring out your ideas fast on paper, is fast and then it's inexpensive. It's just a piece of paper and a pen or a marker. It's possible to make instant changes and test new iterations because you haven't spent so much time to it. Because you haven't spent so much time with it, you don't have an emotional connection to whatever you're doing. When you write something on a piece of paper, you can just crumple it up, and so it makes it easy to change your mind. And so, like because you've invested time into it, basically, it's easy to leave it and then take another idea if you realize that idea is not the right one or it's a useless idea. Basically, it's disposable and you can throw away. So basically, what I was saying, because the ideas are, you're just writing it on paper and you haven't wasted so much time on it, you can just throw it away and then pick another piece of paper and then start writing, because like you haven't spent so much time on it, and so it's disposable. And then it encourages and fosters design thinking. So again, design thinking is an iterative process. It's a process that is like you're always trying to improve something, right? Or you're trying to understand, you're trying to understand the user, understand the problem, then ideate, and then you prototype. If that prototype does not work, you need to go back to ideate, and then you need to get new ideas. So basically, because low fidelity is fast-paced and quick, you are able to go back and then like make your iterations, because design is an iterative process. So because it fosters that iterative process, it makes low fidelity great for like design thinking, because if you're not firm on what you believe in, you can't progress into high fidelity. What are some of the cons? The inherent lack of realism. So again, because you haven't spent so much time with it and it's just a sketch on a piece of paper, it's not real. So like, because it's not real, it's difficult for somebody to visualize exactly what you have on the piece of paper, and then that makes it hard to test because the person does not see what the full thing is. The next one is prototypes. The prototypes that lack the look and feel of the product may lack a validity. So prototypes that lack the look or feel of the product may lack validity. So this is tied to this, because this does not feel real. Then when the user is testing it, there's no seriousness to how they are actually testing that particular thing. So if they lack context to what exactly is going on, they can't provide the right type of information you want to receive from them. And so that is how it lacks validity. It does not feel like it's real. Alright, so the other thing is, may remove control from the user, as the designer would probably have to explain certain parts. Again, all of this is tied to the realism. So because the because it does not feel real, and then the user needs some sort of information to understand what is going on, the designer would have to explain, okay, this is supposed to be an image, this is supposed to be this is supposed to be that. Once the designer is explaining all of those things, the designer is basically, because when you are designing a product, you want to design a product in such a way that when the designer is not there, the person should be able to use the product. But now the designer is there and explaining how to use the product to the person on paper, and so automatically it invalidates what the design testing is, basically, because the designer is explaining what is going on, and that is not supposed to be the case. The designer is not supposed to explain what is going on. All right, so the next one is may not be appropriate for what you are creating it for. So again, if you are maybe you are creating a dashboard interface for example, and then you are using a low fidelity prototype, if how do you explain to the person that when you click on here this would happen and this would pop up, or when you click on this would happen? Like, how do you explain that to the person on a piece of paper? It's not possible, and so it's not appropriate for and so it's not appropriate for it may not be appropriate for what you are creating it for. The next one is we're basically talking about high fidelity prototypes. So high fidelity prototypes look much closer to the end results. Basically, so for example, a high fidelity prototype could be a 3D plastic model that has moving parts and allows the user to feel the function of the product. This would be considered high fidelity rather than low fidelity, because this would give the user a close experience to the end product, and let's say a block of wood. So as a software prototype, a depiction of the product made in Figma and XD would be considered high fidelity rather than a storyboard. Again, so I'll base this on this last bit over here. So again, like using the dashboard example we gave, if we create the prototype in something like Figma or XD, and then you can see everything, and then some prototypes are so good, end users think they are actual products. Like, I've had experiences like that where in the prototype we had to stipulate that this is a prototype and that certain features may not work like expected, because people expected text fields to work, and then it was impossible to make that happen in Figma. And so high fidelity brings the user to what the final product might look like. It's like majority of the time it's almost one of one, like it's almost it's very identical, where it's difficult to tell them apart. And that is where that's where almost every designer wants to be. Every designer wants to be at a situation where their design is exactly what is built, and then it looks good enough as well. All right, so then the pros of high fidelity, they are more engaging for the users. I think that is counterintuitive, because they are very well built. The users can engage with them better, and so this is like vice versa of what the first con of what low fidelity was. And then users are more likely to navigate the product alone without needing a step-by-step explanation from the designer. Again, so because the high fidelity is so good, like people add interactions, and then the user is able to basically know their way around the application by figure all of that by themselves, because it feels very close to the real product, and then they can interact with it like a real product. Then the closer the prototype is to the finished product, the more confidence the designers can have as to how users will react to the final product. So if I design a product and I know that the final product would be the exact replica of what I have designed, the prototype I have, then if we've tested it and then we are getting positive feedback, then it's automatic that the final product will give me positive feedback as well, because the final product is basically a replica of the prototype, right? So that is a pro of the high fidelity design. Then stakeholders can instantly see the end product and will be able to judge more detailed aspect of the final article. So stakeholders are basically the owners of, so like if somebody employed you to build the software, the person is a stakeholder of the software. And so when you design the software, and then that is what happens majority of the time, where the developers, when you design the thing, the developers would look at what you designed to build the final product basically. So if you design it now, and then the developers would create the exact replica of what you've built, then the stakeholders can see what the end product looks like before it's actually built, because the developers are trying to replicate what you've done in Figma or in XD. And so it makes it possible for the stakeholders to see it. That's the same thing. There's a similar example would be what architects have, those little buildings that they have and then use for their presentations. Their stakeholders, like when they go into meeting rooms and stuff, they send those scaled down versions of the building to the meetings to show the stakeholders, okay, this is what we have built and this is what we envision it to be. This is what it would look like. This is what the environment would look like. And then when it helps the stakeholders envision what the final thing is, because we are showing you a scaled down version of it. So just multiply it to whatever scale factor you want to measure it by, and then you can see what's the vision of the designer basically. So those are the pros of high fidelity design. The cons are, obviously, they take a longer time to produce because there's so much more time spent into it rather than sketching stuff. Because of the realistic aspect, users will be more prone to asking questions about characteristics that you don't need observing, as they won't be in the final product. So this one is an effect of the thing being so detailed. Sometimes when you test the product, and then some users would be complaining about certain things like color, and then it's like an anomaly, but maybe it's one person who's complaining, and then they are complaining about it, but because it's like the exact replica, you are getting observations that are irrelevant or some things that might change. And so like because of the realism, there are certain stuff to pay for testing, because you know that when you want to satisfy, it's impossible to satisfy everyone, but you want to satisfy majority of the people. But when you create something that's so realistic to what the final product might be, people want to give you certain feedback that you might not want. And so that is one thing to consider as a con. And then after spending so much time on a prototype, designers tend to want to not implement changes that users mention due to the lack of time. So this again is an example of a vice versa of how low fidelity is a throwaway. So with right, this is supposed to be high fidelity. So how low fidelity is a throwaway. So with this one, is basically because I've spent so much time with this particular product, I'm invested into it. And so when we actually do the testing, and then the end users provide the feedback that we want, and then something needs to be changed, it becomes difficult for the designer to actually change it, because they spend so much time into it and they are invested into it. It looks good to them, and so they do not understand why they need to change it. And so that is a con of high fidelity design, where this is a mistake. This is supposed to be high fidelity in my error. So that is a con of high fidelity prototypes basically. So the guidelines for creating fantastic prototypes. So yeah, just start building. So what this means, your best bet is to just start making something. Creating a prototype will help you think about your ideas in a concrete manner, and potentially allow you to gain insights into ways you can improve the design. So again, until you've started something, you cannot judge how well it's going. So the best way of building stuff is to just start your prototype. Once you're building the prototypes, you get ideas, and then when you get the ideas, you can implement those ideas in the ideation stage. So like we mentioned, design is an iterative process. When you go forward, you definitely come back and add something. You get an idea somewhere. So one thing when I'm building a design is I can do the design, and then when I have to connect the nodes to create the prototype, then you realize that, oh, I missed this screen, I missed this, okay, we need to add this. All of those are things that you missed. But because you are actually creating a prototype, then you are catching onto the things you missed. So the thing about prototypes is just get into it, just start building it. Then don't spend too much time. So the longer you spend building your prototype, the more emotionally attached you get to your idea. This hampers your ability to objectively judge its merits. So again, the more time you spend on a design, the more you become emotionally attached to it. And then when you become emotionally attached to something, it becomes difficult to leave it alone. So sorry for the silence. Oh, 1 second, guys, please. Yeah. So sorry about that. Yeah. So this is, I think this is like the second time you're mentioning this. So don't spend too much time on it because you get emotionally attached to it. So you want to. So I know it seems it's almost like we tell you to spend time to create the prototypes, but don't get emotionally. So it's just you need to be. So the key thing is you need to be in the position to be able to change something. So if it's not working, you need to change it. Don't get emotionally attached. Like always try to not get emotionally attached to the design, please. Then remember what you're testing for. So all prototypes should have a central testing issue. Do not lose the sight of that issue, but at the same time, do not get so bound to do not get so bound to it so as to lose sight of what other lessons you can learn. So this is like um, when you are testing for something, make sure you know what the end looks like. Once you know what the end looks like, then you can how you call it, make sure that you are on the right course in the right direction. But then, because you know what the end looks like, don't allow yourself to be oblivious to the opinions that you might get from the users. Right. So it's like be focused, but allow yourself to embrace like information that is coming in, but know what your target is. But allow yourself to. So it's basically like allow users to take you to the promised land. Don't be like, oh, because I'm heading to the promised land, like because I'm heading in this direction, that is my only focus, and whatever you're saying to me is useless. Let the users take you there. Like, let the opinions they are giving you take you there. If the opinion is not taking you there, try to understand why it's not taking you there, and then make it take you there. All right. So the last one is build with build with the users in mind. So test the prototypes against the expected behaviors and user needs. Then learn from the gaps in expectations and realities, and improve your idea. I think this is straightforward. So the thing about the whole thing about the low fidelity prototypes and the high fidelity prototypes is you need both of them to actually build a particular product. So what happens in real life is the low fidelity prototypes tend to be the what you start out with to basically like prove the concepts you're trying to work with, and then you do the high fidelity to show to the stakeholders and then the people and then the end users for the testing. So it's basically you try to benefit from the cons of both sides. So you want to be fast and then get out your ideas as quickly as possible in the low fidelity, and then you want to explore those ideas that you've gotten out of the low fidelity in the high fidelity so you can test it with the best possible feedback you can get from the end users, because you should understand that in design thinking, for every product that you are designing, the users are the primary focus of that particular product. All right. So please, are there any questions? Or are there any feedback or opinions that if you want something, if you want us to talk about something, if I missed something, you can point in the right direction. Hello. Hello, guys. Hello. All right, so there's no feedback. All right, so all right, since there's no feedback, we'll jump into how many hours? Okay, so we have about 18 minutes. All right, so we want the sessions to be interactive, and so now that we've gotten all the theory bits out of the way, we would jump into actually creating some design stuff. So we have a problem statement that we've already developed. If you want access to the slides that we used today, let me share that. Sharing that over here, so you can check that in the link. So we want the thing to be interactive because we want to explore the whole entire process to actually do testing. And so now that we are prototyping, we want to start to do something. All right. So from last week we did ideation. We talked about ideation. Again, if you missed it, you can check the YouTube. I dropped the link to the YouTube in the messages, and so you can check it out. So now we want to explore some of the we want to basically create a prototype for the problem statement that we have. And so this is our problem statement. So Kofi is a small business owner who needs a system to track and remind clients of impending debt payment deadlines because clients sometimes forget to make payments on time. So this is our problem statement. We've learned about empathy. We've learned about defining the problem, and that's after defining the problem, that is how we were able to create this problem statement. We've ideated, and so the ideations we've done. Not this one. So we have the ideation. So we brainstormed to get myself with some other members of the group, and then we came up with this solutions, ideas, and then we've selected this ones to further our case with, basically further our problem. They might not be the best, but again, this is just for tutorial purposes. We are not building this in real life. It's not for tutorial purposes. And so from the problem statement, we're able to select certain features that would make Kofi our persona. That's Kofi. That would make his business basically boom because people don't want to pay him on time. And so these are some of the solutions that we have come up with. I'm not sure whether to start the the prototyping phase today because of the time constraints. What do you guys think? Should we start that now or should we continue that next week? So like maybe coming into next week, then we are prepared for like getting into actually doing some practical stuff like drawing user flows and stuff like that. Hello? So we should get started or alright, sure thing. Alright. So these are the identified features that we'd want to include. So if they are stacked like this, that means they are a similar feature, and so we can merge them as a particular feature. So from our problem statements, we realized that the best way for Kofi to, and then if you are international, Kofi is a local name in Ghana. Myself, I'm in Ghana. Kofi is a local name in Ghana. It's basically for people born on Friday. Funny enough, I'm a Kofi myself. And so, so every guy in Ghana born on Friday is called Kofi. That's just a cool fact. Basically, these are the features that we plan on including in the application. So, basically, creating invoices so we can track. So, creating invoices, then setting up loan deadlines. So, the setting up loan deadlines is basically in the situation where, so we will add this to that. We add this to this. So it's merged as one feature. Then sending weekly reminders before the deadlines. Then spreadsheet for tracking finances. Creating reports to see how his business is doing. Then fetch the bank transactions to categorize and reconcile accounts with ease. And then keep track of what's in stock. This we actually agreed not to include in feature list. All right, so this is basically the ideation we had, and then you can see that all of these ideas point us in making Kofi's problem go away, basically, because if we can process the invoice and all of that information right in the application or whatever tool we want to build, and then by some more right. Yeah, authentication. Then under authentication, there are two things that might happen: signing or what's the other one called? Sign up, right? So sign up. All right, let me connect these things before we. How do you do this? Yes. Here. What's the shortcut for this? X. All right. So on signing, there are two things that might happen. You might end up actually entering the application or forgetting your password, right? Again, this is coming to me because I have done it a couple of times. But if you don't get it, there are you'd have to basically pay attention to other systems and how they work. So signing if it was successful. So this if this was successful, you'd get access to the home, basically. If signing forgot password. Alright, so sign in forgot password, and then you might get access to the home screen. Yes. So on sign up, after sign up, they collect your details. Then you do account validation. I can actually choose to skip this, but I'm choosing not to, so we can basically get the full picture of the application. Account validation. Once you do your account validation, then you can come here. Alright. So now that we are on home, then we can start to add these features that we have over here, and then how to actually make it good. So the home would contain basically a summary of everything that is happening here, and then so over here now we'll get multiple branches that come from home. So we would want to do something like maybe invoices, add everything on this. Okay. All right. So off the top of my head, so, so this is like create invoices. Again, if you do not understand something, please draw my attention to it. Please, you can interject. I don't mind. So so customers. Should we call them customers or debtors? I'm not sure. Yeah. a little bit of research to understand how the problem, how to understand what the solution might look like. If you are working on something like this, you might want to actually spend some time to understand what might work for the user. Basically, you'd want to explore and expand on that. So from here, we can go here, go here, and then over here. And then under here, we can create invoices. Right. From here to there. Right. So now we can move this over here so it's out of the way of that. Alright. Okay, let me just move it some more. So, yep. Alright. Then the next thing is customers and debtors. So now this will basically show a list of your debtors, and then you can add a new debtor. So I think we should color code this to differentiate it. So, and then we'll color code all of this so they are different. Right. So customers should be green. And so customers, like list of customers. Okay, so customers. What should it be? Add new customer. Add new debtor. So add a new debtor and then see your debtor list. So let's just drop this over. Then debtors. Alright. Alright. Yeah. So under reports, what feature did we have under reports? So we want to see track and managing finances. So bank reconciliation. So this should be under here. This should be under reports. All right. So spreadsheets for tracking finances, track and manage finances, fetch bank reconciliation. So reports. This would probably be like one page where everything is. Yeah. Then my profile we might not go into it. So again, this is a high level view of the application flow. I don't know. Let's go through it. Let's all of us go through it. So, yeah. So this is the splash screen. So after the splash screen, you come to the authentication. So like this gives you the option to either sign in or sign up. So if you go the sign in route, you can. There's a chance you'd forget your password. When you enter your sign-in information and it's accurate, then you jump back to home. So this is for a returning customer. Now this is for a new customer. So if that's a new person who is trying to use the application, so if sign up and then they do after signing up, account validation, that's like the OTP stuff or email validation or whatever validation procedure we want to use. Now when we do the account validation, then the user can come home, right? Once they are home, then you want them to access all the features that you want to include. Let's change the colors for these. Blue for reports and I don't know. Yeah, now let's put my profile. Alright, so once they come home would typically like hold the most important information. Like so home will be dynamic, so like it's actively like showing like maybe who the current debtor is, who has made payments, all of that information, and then they can actually go inside to see who has made payments, and all that. I think we should add notifications to the home as well. It might not be a tab on its own, but we want to add notifications, and then settings, so they can make account settings. Typically, if there are no special features that need to be in settings, it's usually generic, at least for me. And then based on like talks with the developers, then you can identify some of the new things that we can add in settings. And so we would assume that there's nothing special that needs to be done in settings. But if in the development process, when we are actually building the application, then we can expand and then make adjustments and be like, okay, this thing needs to be in settings. If we need to ideate, we'll come back to the XD file, not XD, I mean, sorry, the fig jam, and then make the adjustments. All right. So I think when I go home, I skipped. Okay. So on home, there's the option to check your invoices. So when you click invoices, this I'm assuming would be tabs at the bottom of the screen. Again, I haven't made anything concrete. Like there's nothing that I've said that is concrete so far, because I'm of the notion that I might change my mind. Something might change my mind. Somebody might mention something that would make me change my mind. Because again, you don't want to become emotionally attached to whatever you're building. You want to build it to the best of your knowledge, but that should be the end of it. Like don't get too invested in what you're building. Once you get too invested, when you're prompted to change something, then it becomes a problem where you're like, no. But sometimes you know that there's this thing they say where they say the user is always right. I think the customer is always right. In our situation, the user is always right. So you always want to satisfy the user, prevent the user from complaining. We are all users and we've all used software and then we've complained about it because they were poorly designed. But I don't think any of us has actually used software like Instagram and stuff like that and complained, because if it's not against the company's policy, then it's built the right way. Like something that people complain about a lot is Twitter's what do you call it? Twitter's edit button. But the reason why Twitter does not add an edit button is because of something called non-repudiation. And so it has something to do with security. That is why Twitter cannot add an edit button. Else they would have added it a long time. But because it goes against company policy on security, which is quite important. And so unless the users ask, is something that would violate the software or the product that you are building or you are designing, the user is always right. All right. So guys, this is the flow that we have. I'll go ahead to give access to the folder that has this. Okay, so I think what I should do is I'll give access to, if you've missed the previous sessions, I share the link to this particular project